Right, British Mathematical Olympiad 2 2023 task number 2. So how do we solve it? For integer n greater than 1, the numbers 1, 2, 3 up to n are written in order on a blackboard. So it's not really black, it's grey board. The following moves are possible. 1. Take three adjacent numbers x, y, z whose sum is a multiple of 3 and replace them with y, z, x. Second, take two adjacent numbers x, y whose difference is multiple of 3 and replace them with y, x. So just basically swap them. The examples are given here. So here, like numbers 1, 2, 3, they're swapped first way, and then the numbers 1 and 4 are swapped second way. Find all n such that the initial list can be transformed into this after a finite number of moves. Okay, so let's start trying. First, n equals 2. 1, 2. Does it work? No, it doesn't, because I is not applicable. It's applicable only for 3 numbers, and 2 is not applicable neither, because the difference is not multiple of 3. So no, it doesn't work. Okay, if n equals 3, I try to do 2i steps. I and then another I, so I got 3, 1, 2. And it works apparently. Then if n equals 4, how does it work? I took 2, 3, 4 adjacent numbers and twice make I, and so just in the same way as here for n equals 3. So it becomes 1, and then they are swapped 4, 2, 3. And then I look here and I see 1 and 4, and I swap 1 and 4 by I rule and becomes 4, 1, 2, 3. So it also works. And then for 5, I tried. I first of all took these 3, 4, 5, and I made them I swap 2 times, so they become 5, 3, 4, which in fact puts 5 here in front. So then I made again 2 I swaps to make it like 5, 1, 2, 3, 4. Okay, then what do I see? That for all odd numbers it works. So odd numbers, it's just like number of even pairs with the last number. In this case it is 7. So 7 we put here into I swaps, and then it becomes these triplets. Again, 2 I swaps, 7 goes here, and then 7 after 1, 2, and then 7 goes to the first position, so it becomes 7, and then 1, 2, 3, 4, 5, 6. So it perfectly works. This is the way how it works for even numbers. Then, sorry, for odd numbers, 2k plus 1. Okay, then we see how it's going to work for some even numbers. Let's take 6. So I make again 2 I swaps, like I call sometimes A, and B and I called B. Okay, so I put 6 and then 4, 5. And then what do I do? For these numbers, 3 and 6, the difference is a multiple of 3, so I swap 6 and 3, and it becomes 1, 2, 6, and then 3, 4, 5. And then what do I do? Obviously, for these triplets, I make 2 I swaps. And so it works. And then for 8, it just worked the same way. So 8 I put here, and then 5 and 8 I swap, and then it becomes 1, 2, 3, 4, 8, and then two pairs of I swaps. First for this triplet, 8 is here, second for these triplets. And I wanted to generalize. Does it going to work all the time? So I have n, and then what do? I make 2 I swaps, so n goes here. N minus 2, n minus 1, and before n as it was goes n minus 3. And then I see n and n minus 3. The difference is obviously a multiple of 3, so it always works this way. So I swap them by rule I, and it becomes this. N minus 3, n minus 2, n minus 1 in front, and then this is sub number, and this sub number, because n was even, so 2k, so n minus 4 is also even, and so this number is even in some order, and this is like n in the end, it is odd. And then we just apply the same algorithm that we used here for the odd number. So for all even numbers, it also works. So it works for even numbers, for odd numbers, for even numbers, except for 1, 2. So answer, for all n greater or equal than 3, either odd or even. And yes, if necessary, the number of steps can be calculated, but we were not asked that. So thank you, my friends. Feel free to leave a comment and ask a question. Yes, see you in the next question. Goodbye.